online.
Hello, thank you for joining us today. Today we're going to be reviewing Atago's PAL Milk refractometer here. So for those who are not familiar, this is it's a rather special refractometer in that it will look just at the non-fat milk solids within your sample. So obviously this is just going to concern different milks, not going to have a different measurement principle per se, as it will still use refraction like any of our other refractometers. However, we are on a slightly different scale from 0 to 23% for the non-fat milk solids. So this could have a couple different applications, but certainly if you're checking to see if your milk sample has any sort of additives involved with it and looking for that extra cross-checking measure, this would be a great unit for you. You'll probably also notice we have the PAL pH right next to it. So if you haven't had a chance to check that out in terms of the design, feel, which is basically how it works and the range, we will be taking a look at that directly afterwards as well. I did want to mention that because these are digital refractometers, you are going to have things like NFC for reviewing your data, exporting your data. You are going to have a digital representation of your reading, so these are certainly nice little perks to have that you don't have with a traditional style of the analog. So we'll take a first-hand look at that as well. So first things first, I wanted to give you guys a quick close-up of the PAL Milk and just sort of how it's designed and what we have involved here. Go ahead and change our view here. So this is, for those who have checked any of our other past meetups here, this is actually going to utilize the exact same design. We have the 100-gram compact design here, ergonomic shape. We have the nice angles here for easy runoff of the sample when cleaning. And then of course this is our sample stage here. Your eye's probably drawn right to that blackish area in the center, so this is our prism. That's actually where the refraction is occurring. The light will come from the inside of the unit and project outward, and that's how our measurements are being obtained. We are not using external light sources to generate those readings as you would with an analog. So that's all happening in the prism and the surrounding sample stage area there. We do also have a couple of buttons. As you can see, there's the start and zero. Zero setting I will show you guys in just a moment here, but that's essentially going to get a ground zero established so we can have that reference point, so to speak. So that's basically all you have in terms of the buttons. You can do a couple things with those, which we'll hopefully get a look at here. You can see on the bottom side here, this is a battery cap where all you need is two AA batteries, and you've got a little lanyard hole here for easy transportation and getting about with the unit. So very simple design, nice compact feel, and as you can see, it is right in line with all of our other handheld refractometers. I will just quickly show the PAL pH since we might not get a chance later before we jump right into measuring, but this is going to use the same sort of design. Only difference is we're going to have a CAL for calibration here. So you might be asking, why are we looking at the PAL pH? The reason is oftentimes these units are used in tandem in the milk production industry, whether you're importing or exporting or just reviewing your own sample. Oftentimes it is good to check that your milk is in that similar pH region. I believe it's in the 6 to 7 pH region for that target. So With this unit, very similar design, you are going to calibrate at different points as opposed to zero setting, which we'll show in just a few minutes here. I did want to just give you guys a glimpse of how we would go about measuring. We have a couple different samples here. So one is going to be standard whole milk. The other is a little bit of creamer here, which we can kind of juxtapose the results with in terms of the non-fat milk solids. So let's take a quick look. I'm going to hit start to power the unit on, and you might have noticed when I was kind of displaying the instrument that we have that little mode S written right there. So this is actually a neat feature and something that can only come into play with the digital units, and this is actually using certain measurement principles that factor in the fattier nature of the sample at hand here. So because we are looking at a slightly fattier sample, we are going to use that mode S and still get the same amount of repeatability, that you would normally see some issues with, whether that's HHH, LLL, or any of the various error messages that might come up. We are seeing LLL now, which indicates that our sample volume is insufficient. However, that is no problem at all, so we'll just get a little bit in there in a moment here. First thing we want to do though is zero set. So you can just use regular tap water for this. And again, we are doing this just to kind of establish that ground zero, so to speak, give us that reference point. So I'm going to go ahead and hit that 0 button. We're seeing 0, 0, 0 display there. And another neat little feature, we can actually see the temperature which the prism is actively reading for us. So our tap water sample there is at 20.9 degrees Celsius. If I go ahead and hit start, so this is the measuring process, not the zero setting process. We can actually also see a little blinking light there indicating that it is reading, and that is perfect because we're right at 0.0%, right where we want to be. Do that one more time. And another neat, not so advertised feature of this instrument is you are going to have repeated readings display for you. So we can see, theoretically, if I were changing my sample, if I were adding dissolved solids in there, this 0.0 would be displaying a different amount every time it was blinking. So that's right where we want to be with our zero setting. Now, when you are clearing the sample stage of sample or water or what have you, we would recommend that you are using a lint-free wipe. This is going to, of course, eliminate the possibility of scratching the prism or causing damage. Also, depending on the sample type, this can, lead to sample buildup if you're not doing this on a constant basis. So, always good to clear as much as you can. So we'll take a quick look at our whole milk here, and you really don't need much at all. 0.3 milliliters is all you need. You see our unit is powered on. Go ahead and put in 0.3 milliliters or so. And it's really, with the Mode S technology coming into play, we are getting a nice quick reading there. So every second we're at that 12.3% non-fat milk solids. And just to give you guys an idea, we will make sure that this is kind of acclimating. If you're using a refrigerated sample or a warmer sample for whatever reason, always good to keep in mind that that is going to have a direct correlation with the bricks, or in this case with the non-fat milk solids that is displayed. So you do want to make sure that you control that temperature as much as possible. And one way you can do that is actually with a little add-on that's provided with this this unit itself, and that is the Magic here. So this is the metal version of our Magic. So you can actually insert this in with the sample, and that's going to help get that right to a controlled temperature. And obviously, if there's any sort of external interference, so to speak, this will help keep the sample controlled. So we're getting closer to that same reading, 11.8, 11.7. So all you do with that Magic is make sure you have ample sample volume on there, insert it there, go ahead and hit start one more time. Nice repeatability there, 11.8. So as our sample temperature is nearing that 20.8 degrees Celsius and stabilizing, we're getting a very consistent readout. So this actually is going to feature plus or minus 0.2% in terms of how much you can see that reading fluctuate, but we're getting a lot of really good results here. So just something to keep in mind with the Magic. It may or may not come into play, but just a nice little add-on, because if you are dealing with a milk sample, you may see refrigerated, you may see warmer samples, so just good to get that that stabilized a little bit quicker so you're not wasting as much time. Keep in mind that this unit does have ATC, so it's going to do a lot of the work for you. If you're looking at 10 to 100 degrees Celsius, the unit is going to automatically compensate when it's generating those readings. So pretty cool technology, to be honest. I want to give you guys a quick look at some creamer here, so probably a slightly fattier sample that will use that Mode S technology. And I should mention that this unit here is actually IP65, which is really nice. This is Ingress protection rating for those who are unfamiliar, but it's essentially going to enable you to put this unit under running water, and you are going to have that added protection against dust as well. So nice and durable. We wouldn't suggest submerging it in water, but you are more than welcome to run the sample stage right under that water and get your sample off in an efficient manner. Probably best to also utilize your Kim wipes as best you can, or any other sort of lint-free wipe. So we have our 0 set done, the unit's still on. We can just jump right in and get slightly different sample type here. We are seeing LLL, which again is going to indicate insufficient sample volume, but that's okay. We should now have enough on there. And we can see we're at 20.6, so pretty close to that target that we were at before, probably rounding room temperature here. And again, we're getting that nice repeatability within 0.1%. So again, theoretically, if I were to change the nature of the sample, if I were to change the temperature, we would see this readout here on basically on a constant basis every second. We would see that actively represented. Because things are pretty stable here, we're seeing that same measurement value, but very high repeatability, as we can see with this Mode S technology kicking in. So I did want to give you guys a quick look at the PAL pH as well, since this is often pretty relevant in this particular field here. And the pH, I should mention before we jump in, it's a little bit different. So there is going to be an electrode that's involved. So this is not going to use the standard refraction principles. So we are going to be looking at probably around 6.7, maybe 7 for our pH level of milk, generally speaking. But we'll see kind of how the instrument produces that here for us. And just going to quickly show here, the unit does auto power off, but we can just go ahead and hold that start button and get the same result there. So we have our PAL pH here. And again, we're going to have a calibration button here instead of the 0. That is partially due to slightly different measurement principles, but you are not going to 0 set with any sort of water. Main reason being you are going to have different pH levels in different water on hand. What we do want to do though is get different calibration points set. So what's really nice is this unit will actually come with 3 different buffer solutions for you, and you can verify those at will. So we have 6.86 that we'll definitely look at today. That's right in our range, as well as the 9.18. We may get up to around that region. So we'll just calibrate both those points, make sure the unit knows the low end and the high end. So when we take our measurement here, it'll fall right in between and we can have those reference points established. The unit will also come with 4.01 as well. So if you are looking at a lower pH, many different applications for the PAL pH here. It's very popular in the wine industry as well. You can also set that as well. So for today, because of our sample type and predicted range here, we'll just take a look at the 6.86 first. So I would recommend, we have been using the unit here, I would recommend, generally speaking, that you want to wet the electrodes. So just let some tap water kind of sit in there, seep into it. That will get things kind of going for you before you actually start the measuring process or calibration process. So if I make sure that all is covered there, I'm going to go ahead and hit calibrate, and our unit is smart enough to know that this is that exact pH solution. So it's going right to 6.86. It's established that reference point. If I hit start, we are going to see an exact representation of what we just 0 set with. So, I'm sorry, what we just calibrated with. So that is our first reference point. Get those lint-free wipes going. And again, this unit is also going to have a high IP rating of 65. So no need to worry about exposing it to water to get that sample stage cleared off. Since we have that established, we can get essentially our low end. We can also get our high end here. I'm going to go ahead and hit calibrate. And the unit does recognize that we're right at that 9.18 pH range. Go ahead and hit start here. We are seeing AAA come up. This is when we have an error with that calibration, but that's anticipated because we're switching to gears here. So this is going to have an accuracy fluctuation of plus or minus 0.2 plus 10, I believe. So plus or minus 0.10 with the pH, which is right within our boundary there. So we've got our low end and our high end established. So now we can check what our cows are producing for us in terms of the pH level. We've got our non-fat solids, and now we're looking for our pH in this whole milk here. Just add a little bit more. And generally speaking, you do want to avoid kind of involving bubbles with your measurement. Because the pH meter functions a little bit differently, it's actually going to, there's a little bit of a sponge in there that's going to take in some of the solution. This should be fine. Good to keep in mind though when you are using refraction to eliminate those bubbles as much as possible. I'm going to go ahead and hit start here. And we can see it is right in that range, right? So we had our 6.86 to 9.18, and it's right in the middle. And what's really quite remarkable is the speed with this instrument, right? So a lot of other pH meters, whether you have a probe, whether it's more like a dipstick style, they are going to generally not perform with this amount of efficiency. You can just see it's just maybe even under 2 seconds there, and we're getting that nice repeatability, 6.68, 6.69, and we are getting that 20.7 degrees Celsius, so exactly the same as what we were seeing with our PAL milk unit as well. So nice little features for both of those, and I did want to just reiterate, this does have NFC, so you are able to look at your data, compare it with the past and see how your samples changed, and that can be, there's many different options with those NFC apps that you can look into. So I did want to open it up if there are any questions. This could be regarding the PAL milk or the PAL pH, so please submit if you do have any. I did want to mention that next week at the exact same time here, 10:30 Pacific, we will be doing a meetup on the PR101 Alpha. I will be running that as well. So the PR101 Alpha is going to be an introduction to our portable benchtops here. So these have many different applications, which we'll get into a little bit. But you are going to have that kind of higher accuracy refractometer that we'll take a look at. So see if there are any questions here. I think we're okay. If you guys have any follow-up questions, please feel free to reach out here at Otago USA. Thank you so much for joining.